transplantation. Normally they're using complicated sutures like cardiac valves that are hard to repair. Okay. So right here is a picture of artificial tissue. This is actually has no human cells in it. It is tiny little strings that are basically used to coat things like organ or mostly right now skins like burn victims. They sometimes put this on it. What it does is it just acts as like a cover so it can heal faster. It's not necessarily like a substitute for skin. It's not a permanent fix, but it will help create new cells. Okay. A technique on how to engineer tissue. So this is what we'll be doing in our lab. To create these tissues, we will have to get stem cells. So to create stem cells from our own tissue, what we do is we take fibroblasts from our bone marrow, we induce them using a retroviral system, and then we will culture them. We do this by sticking them in an incubator. Incubators create an environment. They're set at certain temperatures to mimic the environment. In this case, they mimic the human body. And then we put them in the extracellular matrix. Now, as we have learned, the extracellular matrix will create the resources the cell will need to survive. Make sense? Any questions? None at all? Okay, sounds good. So in this lab, we will actually demonstrate creating induced pluripotent stem cell tissue grafts. Alright? So just real quick before we get to do this, in this lab we'll demonstrate how scientists create tissue grafts. This will simulate the steps needed to create a successful graft. Minutes in this context will represent weeks. Alright, cool. So unfortunately, we have a patient with a third-degree burn. So this is the patient's, well, their hand, but there's a few things you have to know first. So this is our incubator. This is our retroviral system. This is the adhesive that we will apply around the graft. And these are our extracellular matrices. Okay, so as we see the instructions over there, first thing you have to do is remove fibroblasts from the patient. Alright, so who remembers where the fibroblasts are located that we're going to culture?
Bone marrow.
Perfect, bone marrow. So as you guys can see, we have little bone marrow cells. See that? Fibroblasts. So what we're going to do is, whoever wants to do it, Chris. So what you're going to do is you're going to remove one of those cells and place it in the extracellular matrix. You got it? Alright. Do another one too.
Can I do this one? Do you have like a drill or something? Got it. Left one or right one?
The right one. You have two separate extracellular matrices. Alright, so right now what we have to do is we have to induce these fibroblasts. So what do we use for that? What do we use for that? The thing, the green thing.
The retroviral
system. Perfect. Alright, so what we're going to do is we're going to just take 2 drops of the retroviral system onto the cells. Perfect.
Excuse me.
Okay, so now that we injected the retroviral system, what we have to do is we have to incubate it for 2 weeks. For this instant, it's 2 minutes. Alright, so we're going to put the lids on here, and we're going to put it in the incubator. Alright.
And what temperature is the incubator at? Body temperature?
Yes, body temperature.
Okay.
And what temperature is that?
98.6?
There you go.
You didn't know that.
Alright, so after 2 weeks, we're going to remove the skin grafts, and look! We have made skin cultures! So now what we have to do is we have to size the skin cultures and place them on the wound. and we put adhesive around the edges of the wound. All right. So who wants to apply it?
So in
I
real
think
life,
Laura-
this
yes,
would just
Laura's
be
actually
like
been
a
asking about
lard of
this.
skin.
Yes. Actually,
Oh yeah, Terrell.
yes.
Let's ask Terrell.
It's
Terrell.
a nice layer of skin. All right.
Okay.
Tori,
Terrell would love to.
Okay.
so put the adhesive around the wound and then around the skin graft.
In the wound or on the wound? Or the black part or the red part?
You want it on the skin.
The singed?
No.
So the
it's
live
skin.
cells.
The live cells.
Okay.
Yes.
Thank you. I didn't know what I was really trying to ask, but I'm really excited.
Chris, you just go back.
Go, Tori.
All right. So in real life, when you're adding the adhesive, has to be able to be digested by the human body, or actually the graft will not take, because it will find the sugar, the glue as foreign, and it will start attacking that, which therefore will start attacking part of the skin graft. So
it's
that's why
edible glue?
it has actually edible glue.
Oh,
Normally
does it
it's
taste good?
sugar based.
Yeah, it's sugar based.
Oh, so it tastes like sugar.
Actually, no.
Could you just,
Because
like,
there's a
stick
lot
it
of
in
other
it? It tastes like
additives.
sticky.
It's probably not sugar, it's probably something like
Oh, that's not fun.
a glucose base that your body can break
Handle,
down
yeah.
and
Yes.
use. Not something that we eat.
Actually,
Yeah.
yes, exactly.
Okay.
I
got
so that one.
let's
but I need
introduce
that
that
one. So smart.
Look at salsa.
No, I think we can just apply it. Who wants to apply it?
I'll apply.
Laura.
Sweet.
She's had her eyes on that.
She
Apply the
loves.
skin graft.
She loves applying things.
Nick hasn't gone yet. Can you do the next one?
Yeah, he can do the next one.
Yeah, try.
Beautiful. All right, Nick.
Yeah, the next one too.
Yeah, just apply that adhesive. Adhesive on the wound has already happened, so apply the adhesive on this one. Just real quick. Doesn't have to be a very
Go
thorough.
fast, the guy has a third degree burn. He
Slower.
needs help.
Can't feel it. There's no
Once more.
bone.
We feel it.
Yeah, but you can see this.
You can see my
You
bone.
know, the squeamish can leave.
Sorry if this is too weird.
It's getting too real for me to go.
Beautiful. Now let's apply it. And now, after 5 weeks, the graft should fully heal.
Well, you have an unusual lump on your arm from all the
No, it would just,
over.
No,
it would just be like,
it's like
yeah.
that. It doesn't even, you can't even
Oh,
tell.
so that's a skin graft?
I had a
Yeah.
3rd-degree burn.
Is that not real
Oh.
skin?
Okay, so
Are you a- are you a cyborg?
so after 3
Are you a
weeks,
cyborg?
after 3 weeks, this arm will be healed, and the person will be just fine.
Cool.
All right, so this is just real quick is a picture of the retroviral system being injected into the cultures. Okay. The future of tissue engineering. Future tissue engineering looks bright and is quite possibly the future of medicine. Growing new organs would save many lives. The economic outcome will be amazing. An estimated cost of creating an artificial pancreas will be around $20,000. Now, for those of you with diabetes, this could really help. Because as you know, diabetes can be expensive, and a new pancreas can save you thousands in medical costs. Now, these are just estimates, but a typical diabetes patient with insurance pays around $2,400 a year. In 20 years, that's $48,000. Now, if one surgery with a tissue that's created from them is $20,000, they can save thousands of dollars in the future. Okay. For another example is a person with a kidney transplant. If they could just get an engineered kidney, they would not have to go through the huge process of being waitlisted for organ transplants. And they can just get their tissue implanted in them. So that means no longer medical costs for dialysis while waiting for a match donor. Overall, the process of growing organs is much less expensive than organ transplants, making it much more accessible and ultimately saving people's lives. Another issue with current organ transplants is sometimes the organs are rejected. As we learned before, what that means is your immune system will attack the organ and it will be transported through your waste. Some processes, the person will die because of this. But that will be impossible if we create these induced pluripotent stem cells, grafts, and create new organs. They cannot be rejected because they're made from our tissue. The estimated price of a growth organ will be much less and it will be more accessible. It's estimated that it will take less time to grow an organ than it is to receive an organ off the organ waiting list. People have been on that waiting list for years. While medical expenses have been piling up. Growing organs will then save lives and save people's money. In the future, we may be able to create any tissue grafts. This will help us repair any tissue damage without any scar tissue. For those of you that know scar tissue, can create a lot of problems with any kind of injury. Muscle tears can be healed quicker using the same process. And this could help treat diseases like muscular dystrophy. Neuron grafts could heal diseases like Parkinson's disease. You could create a lot of cures for a lot of terrible, terrible diseases. Okay, so I just want to ask you guys real quick if you guys can think of any possible uses for tissue engineering that I have not stated already. I mean, what could it be used for? Chris?
If someone hits you really hard in the back of the head with a baseball bat, you could use it to regrow the skin and hair.
Yeah, I mean, instead of plastic surgery, they could create new skin. Yeah.
Maybe you get spinal injury. And
Spinal injury, perfect.
so if say you're playing football, you get hit just right and it severs your spinal cord at your waist and you're paraplegic and
Yeah.
you can't use your body from the waist down. Maybe with the stem cells, they can create those new nerve cells that will allow you to get that connection back and you'll be able to walk again.
Yeah, and they can actually create new bone. That would
Really?
be pretty cool. Yes. Well, not yet, I'm saying. Possibly. Anybody else? Nick?
Could they use it to create new prosthetic appendages, arms or legs?
Well, it wouldn't be prosthetic anymore. I mean, this is like really, really, really far into the future, but they might be able to create new appendages.
Do you think they could create an entire new human?
See, this is where it gets really theoretical, because theoretically, that is possible. Alright, cool. So that was pretty good. Alright, so now I'm just going to quiz you guys. See if you were paying attention during the lesson. Alright, so we're going to start off is, what are some common uses of smart materials?
Would one be breast augmentation?
Yes, it could be. Anybody think of any other ones?
That's it.
Pacemakers.
Pacemakers,
and,
yes.
Contact lenses.
Contact lenses, perfect. What are some diseases that tissue engineering will not help, even in the future? Chris?
The genetic ones.
Genetic defects, perfect. What is used to store and feed cells when being incubated?
Extracellular or matrix.
Matrix, perfect. Alright, what kind of adhesive do medical professionals have to use when implanting objects in the human body? Yes?
Sugar-based.
Sugar-based, perfect. Any glue that can be broken down by the human body naturally. Okay, what are some advantages for organ transplantation using tissue engineering? Vinny?
People won't be waitlisted because there'll be more organs available,
Yeah.
and also because it's made from their or derived from their cells, it won't be rejected by their body.
Perfect. Anybody else?
It takes a lot less time to grow a tissue than it does to wait on a waiting list.
Perfect. Well, thank you all. It was fun teaching you.